In this video, we're going to talk about how to find the trig functions using the unit circle or a circle in general, as well as the Pythagorean theorem. We're going to do this whether we're given a point or whether we are given one of the trig functions and then the quadrant that the angle resides in. So just a quick reminder, these should be on your note cards, and if not, pause the video now and write them down. So it's really these bottom three that I'm kind of focused on. So if you have cosecant, that's the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And then kind of the other reminder we need to have in our mind is the SOHCAHTOA. So we've gone over this a few times. Remember, sine of an angle is the opposite divided by the hypotenuse. Cosine of an angle is the adjacent divided by the hypotenuse. Tangent of an angle is the opposite divided by the adjacent. And all of these will help you find these identities. So what we are going to be doing today is finding sine, cosine, tangent, cosecant, secant, and cotangent, given some information. So here's our first sample problem. Find the exact value of each of the 6 trigonometric functions for the angle x with a terminal side containing the point -4 and -3. Terminal side just means that's where the angle ends. So let's talk about what this looks like. We know that all angles start right here. So this would be like our 0 degrees or 0 radians if you're in radians. But we also know that this is our x-axis and our y-axis. So we can graph this point. -4, -3. So that's this point right here. That is -4, -3. So I'm going to draw a line to connect this. So this is the angle I'm trying to find. So the whole angle is this value over here, but I'm going to use what we call a reference triangle to find these exact values. Because what I need to find is I need to figure out what sine of x is, cosine of x, tan of x, and then their reciprocals, which would be cosecant of x, secant of x, as well as cotangent of x. And I'm going to be using SOHCAHTOA to do this. That means sine is the opposite over the hypotenuse. Well, I need a triangle to be able to do that with. So anytime I draw this radius, and that's what this is because we've got kind of a implied circle here, and I'm not very good at drawing circles, so bear with me here. Ooh, that's a terrible circle, but it connects. So we've got this circle here, and we're going to draw a triangle within the circle so that we have a right triangle. Once you draw this radius, you always connect it to the x-axis. That's the easiest way I've found to do it. And then we actually have our triangle. So we have a little right triangle right here. And we can use this point to find 2 of our sides. So -4, so I know this is -4, -3, and this is -3. And then this side right here is going to be our radius. And I do know to find our radius of any right triangle, we use this thing, a squared plus b squared equals c squared, or in our case here, r squared. So I'm going to plug this in and say, okay, -3 squared plus -4 squared equals, let's do this different. Let's do r squared because that's what's in our picture. So 9 plus 16 equals your r squared. So 25 equals r squared, or 5 equals r. My radius is always positive. If you're familiar with Pythagorean triples, this is also a 3, 4, 5 triangle. But now that I have this, and my angle is always this angle right here at the origin, I can find sine, cosine, tangent, which means I can find cosecant, secant, and cotangent. So let's do this. Sine is opposite over hypotenuse. So that's why I put the negatives on this, because typically on a triangle, side lengths aren't negative. But because of where we're at in the triangle, we have to identify whether sine, cosine, or tangent are positive or negative. So I'm going to say opposite over hypotenuse, -3 over 5. So sine is -3 over 5. And the easy thing about this is if sine is -3 over 5, cosecant is just its reciprocal. So it's -5 over 3. So now let's try cosine. Cosine is adjacent over hypotenuse, or -4 over 5. and then secant is its reciprocal. And then tangent is opposite over adjacent, which would be -3/4, -4, whereas two negatives make a positive. So I'm just going to say it's 3/4. Cotangent will be its reciprocal. I just found all 6 of my trigonometric functions. So it all boils down to the Pythagorean theorem and making sure you're labeling your positives and negatives correctly. We're going to talk about this later, but we also have this little thing that helps us remember positives and negatives. And I'm going to actually talk about it on the next problem here. So quadrants. Let's see if I can draw this. Ooh, you know what? Let's do it this way. It'll be a little bit easier and give you a better feel of it. Okay. So here's a circle. We're just going to draw our X and Y axis through this. Not the most centered thing. There we go. All right. So we've got this circle. Here's our x-axis, here's our y-axis. And then I don't know if you remember early on when, like in previous classes where you talked about the quadrants. But this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. And we use Roman numerals kind of to show that. But we can also use this to determine our signs of these trig functions. And by signs, I mean, are they positive or negative? So the way I remember it is this A, S, T, C. And we'll get more into this in our next lesson for sure. But the way I remember this is all students take calculus, starting with quadrant 1. All students take calculus. This tells you which trig functions are positive in each of these quadrants. So the A here, it stands for all. So all trig functions are positive in quadrant 1. The S, this stands for sine. Sine is positive in quadrant 2, as well as its reciprocal cosecant, but we're only worrying about those basic sine, cosine, tangents first because their reciprocals will follow suit. T being tangent. So tangent is the only one that's positive here. That means sine and cosine are both negative down here. Up here, sine is positive, so cosine and tangent are negative. And then right here, the C is cosine. So cosine is positive in this quadrant, but tangent and sine are not. So this helps us when we're looking at a problem like this. So we've got a problem, and it says cotangent of x equals 4, and x is a quadrant 1 angle. So I'm going to erase these values here, but I do want you to, actually, let's do this. I'm just going to shrink them and get them, maybe. The plan was to get them out of the way. All right, we're just going to move those over there so that we can still have that, but I want to draw another one. And then our circle. Okay, so once again, we have our circle here, and this time it's telling us cotangent x is 4, and x is a quadrant 1 angle. So if we know this is quadrant 1, I'm just going to draw an angle in here. It doesn't have to be exact. It really doesn't matter. But what I'm doing is I'm saying, okay, this is x. And then I'm going to draw this straight to the x-axis because that's what I do. And now cotangent. So we want to find all the others. So we still need to find sine of x, cosine of x, and tan of x, and the reciprocals. So cosecant of x, secant of x, and then we've already got cotangent of x. We already know that that's 4. So now I'm going to go through and find the one function I can find without even having to look at the shape here, and that's tangent. So if cotangent is 4, tangent's going to be 1/4. Now how does that help me? Well, I also know that tangent is the opposite over the adjacent. If my x is here, my opposite over adjacent. So this is 1 and this is 4. Well, if I have those, I can definitely find this angle up here. Remember, I can do 1 squared plus 4 squared equals that radius squared. So 1 plus 16 equals r squared. 17 equals r squared. So r, or this radius, I'm going to leave it exact, is the square root of 17. And the reason I'm leaving it exact is because this right here, find the exact values. So I need that square root. Now I can find all these others. I have all the sides, and I can find sine, cosine, and tangent. Sine being opposite over hypotenuse. So it's 1 over square root 17, which means cosecant's the reciprocal, or square root 17 over 1, which I don't have to put the over 1, so it's just square root 17. Cosine is adjacent over hypotenuse, or 4 over square root 17. Secant is the reciprocal of that, so square root 17 over 4. Hey, look, you found them all. So let's go through and do this again. And I will say the reason I kept this over here and the reason I haven't introduced this is I can check. If it's here, all of these should be positive. Is everything positive? Yes. So you did that correctly, your signs. Let's try another one. This time I'm not going to draw out a fancy circle. I'm just going to kind of draw a general one. So this is a quadrant 3. So 1, 2, 3. So my angle's somewhere down here. It's on a circle, but I'm not going to draw the circle. I do go straight back up to the x-axis. Once again, I'm going to find sine, cosine, tangent, sine, cosine, tangent, and the reciprocal. So cosecant, secant, cotangent. I write all 6 out, whether I have them. I know I have this one, so I'm going to go ahead and write that as negative 25 over 24, which means I also know this one is negative 24 over 25, which makes this triangle a little bit easier. So remember, our x is always at the origin. Sine is negative 24 over 25. So sine is opposite over hypotenuse. So I'm going to do 24, 25. Radius is always positive, so the negative is coming from this one right here, which if I look, it'll be a negative, negative. So I know this side will end up being negative as well. But let's go ahead and figure this out. So I've got x squared plus negative 24 squared equals 25 squared. So x squared plus 576 equals 625. So 625 minus 576 is 49. This happens to be another Pythagorean triple. So this will be 7. So it'll be negative 7. And the reason why it's negative, because remember when you square root, this always introduces a plus or minus. Well, because it's going to the left, we know it's the negative one. And now I can find all of these. Cosine being adjacent over hypotenuse, or a negative 7 over 25. And it's reciprocal, negative 25 over 7. And then tangent, opposite over adjacent. Negative over negative is a positive. So 24 over 7. Reciprocal is 7 over 24. My all students take calculus. Tangent should be the only one that's positive. And it is. So you did this correctly. So that's finding the trigonometric functions using a unit circle type approach.